This is Mars. Not from a rover on the ground, not from an orbiter circling above, but captured by NASA's Psyche Spacecraft on May 16, 2026. During a gravity assist flyby, what you're seeing first is something rarely photographed from this angle. The south polar cap of Mars, a frozen expanse of carbon dioxide and water ice sitting at the bottom of the planet. About 170 million miles away from where Psyche snapped those photos, NASA's Curiosity rover has been doing what it does best, slowly, methodically exploring the Martian surface. It's been up there since 2012, drilling into rocks to collect powdered samples and feed them to onboard science instruments. On its latest drilling attempt, something happened that genuinely shocked the engineering team back on Earth. Curiosity drilled into a rock, went in about 6.5 centimeters deep as usual, and when it tried to pull the drill bit back out, the rock came with it. The entire rock, lifted clean off the Martian surface, hanging in the air, stuck to the end of the drill like it had been glued there. Images beamed back to Earth showed what looked like a rock floating above the ground, and the team had to spend nearly a week shaking, vibrating, and maneuvering the arm just to get it off. Eventually, the rock fell, shattered on the surface, and the crisis was over. But for a few days, one of humanity's most sophisticated pieces of machinery on another planet was just stuck, holding a rock. That's what's left of the rock that held Curiosity hostage for nearly a week. Here's how it finally ended. The team tried everything. First, they ran the drill's percussion mechanism for over half an hour, essentially jackhammering from the inside, shaking the bit as violently as the system would allow. Dark basaltic sand came loose from the cracks in the rock, but the rock itself? Still there. So they escalated. They began moving the rover arm in slow, deliberate arcing motions, what the team calls rover tai chi, carefully swinging the stuck rock back and forth, trying to work it free through controlled movement and vibration. The rock held on, then held on some more. And then, sometime in the 4-minute gap between two camera shots, it just let go. No dramatic moment caught on camera, no slow-motion finale. Just rock there, rock gone. It crashed to the surface and broke apart. And Curiosity, completely unfazed, was ready to keep going. Because as it turns out, the engineers had planned for exactly this kind of scenario back during the original design phase. And while Curiosity was busy wrestling with a rock on its drill, its younger sibling was doing something equally remarkable, just 3,775 kilometers away. Look at this panorama. While Curiosity is venturing into ever younger terrain in the foothills of Mount Sharp, Perseverance is doing the opposite, pushing deeper into some of the oldest landscapes in the entire solar system. Two rovers, two missions, two completely different chapters of the same story. These wheel tracks cutting across the Martian surface. Each one is about 50 centimeters wide, pressed into soil that hasn't been touched in billions of years. Dust and crushed rock from a world that used to be something else entirely. Ground-penetrating radar aboard Perseverance has confirmed that Jezero Crater, the very place the rover landed, once held a vast lake and river delta, with layers of ancient sediment still sitting at the bottom of the crater floor. The ground Perseverance is rolling over right now was, billions of years ago, the bed of a Martian lake. And the soil it's stirring up? It's not just dirt. The rover has found mudstones containing organic carbon and unusual textures hinting at possible biosignatures, the kind of chemical fingerprints that, on Earth, are left behind by living things. And then there's the rock nicknamed Cheyava Falls. Scientists found strange leopard spot patterns on it, tiny specks enriched with iron phosphate and iron sulfide, compounds that on Earth are byproducts of microorganisms consuming organic matter. Nobody is saying life existed on Mars, not yet, but the chemistry is there, the water was there, and the clues keep piling up, one wheel track at a time. This is what Mars actually looks like when you get right up to the surface, not the sweeping rust-colored vistas you're used to seeing. Inside a rock called Cheyava Falls, Perseverance's instruments revealed a striking pattern of mineral rings, tiny spots composed of vivianite, a hydrated iron phosphate, and greigite, an iron sulfide, arranged in structured reaction fronts beneath the surface dust. Those brownish flecks and dark formations you're seeing aren't random. On Earth, vivianite forms in peat bogs and around decaying organic matter. Greigite is produced by microbes as a metabolic byproduct. And there's more. Perseverance has also identified microscopic grains of corundum, the mineral that forms rubies and sapphires, inside Martian rocks, the first confirmed detection of this material on Mars, found under conditions that simply shouldn't exist on a planet without active plate tectonics. So what are we actually looking at here? Rocks that are 3.9 billion years old, chemistry that on Earth only happens one way, minerals that have no business being there. Mars isn't telling us there was life, but it's not telling us either. And that, right there in that little patch of reddish dust and dark mineral rings, might be the most important photograph ever taken on another planet.